Where is this vertical asymptote when x is what? 2. Where do you think they got 2 from over here? The bottom, I heard. I like that. Do you agree if I put a 2 right there, 2 minus 2 is 0? Okay. What about over here? Here's the function. They're saying the vertical asymptote is at 3. Do we still get it from the bottom, do you think? Yeah, okay. Here's this function here. They said the vertical asymptote's at 0. Do we get it from the bottom? Yeah. So you guys, in order to find the vertical asymptote, you always set the what equal to 0? Denominator. Boom. Denominator. Great. If my function is undefined on a vertical asymptote, do you think I can ever cross it and have like a point there? You can't. You can never cross a vertical asymptote, never, ever, ever. So I'm going to say vertical asymptotes are never crossed. And in order to find that vertical asymptote, just like you guys said, the bottom. You always set the bottom or the denominator, denominator equal to 0. How did they get 0 over here? When is x squared equal to 0? What would you do to solve for x there? What's the opposite of square rooting? Square rooting. What's the square root of 0? 0. That's where they got that. Okay? So you always just set the denominator equal to 0 every time, and that's going to get you the vertical asymptote. We're going to look now at page 24. I want to point out what makes something have a whole. So it says a whole is when we have a common factor in the numerator and denominator. You're like, what are you talking about? Well, let's first go to the graph. So this graph looks like it doesn't have a whole. In order to figure out if we do have a whole, we got to factor the top and the bottom and see if they've got any common factors. This is our review from Friday that Toby didn't do. 1x squared on the top and the bottom. Do I toot or O-toot when it's 1x squared? Toot. I'm going to toot. What multiplies to be 3 and adds to be 4? 3 times 1 is 3. 3 plus 1 is 4. So you guys, the top factors out to be x plus 3, x plus 1. What is the bottom going to factor out to be? Again, I can do toot because it was 1x squared. What multiplies to be negative 6 and adds to be 1? Negative 2 times 3 is negative 6. Negative 2 plus 3 is 1. Nice, Ficus. So then I got x minus 2, x plus 3. You guys, does this have a common factor in the top and the bottom? Do I have the same thing in parentheses? Yeah, don't I have an x plus 3 up here and an x plus 3 down there? You guys, therefore I have a whole. I have a whole wherever that common factor is when it's set equal to 0. When does x plus 3 equal 0? When x is negative 3. You guys, so I'm going to say the whole is at negative 3 something. We don't know what it is, but I got my whole is at negative 3 something. If you've written that down, I also want us to write down what's left when we got rid of the whole. What happens when I cancel the whole out? Do you agree I've got x plus 1 over an x minus 2? X plus 1, x minus 2. And I want you to put a big old box around that. This is what all of these other answers are going to be based off of this alone. I'm never going to go back to this. Today, we're only talking about wholes and vertical asymptotes, but the rest of this will also just be determined from here. Real fast. Could we go to our calculators now? I want everybody, okay, I'm going to give you some weird requirements. Can we go to Y2? I want us to type in this new one. This new one, we got x plus 1 over x minus 2. Before you hit graph, I want you to do the left arrow and change your line to look like the ball. And mine, I don't have the ball option, so I'm going to have to film someone else's. If you don't mind, Vic, do you mind if I film yours?
Yeah, what am I doing?
So I want you to go to, let me put this here. Okay. I'm going to film over your head. Boop. Okay. So would you do y equals, top left, and then down arrow. Watch what he's going to do. We've never done this, you guys. I just think it's so fun. Go to the left now to where it's the red. Left, 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 left. There you go. Hit enter. Now go down arrow to line, and I want you to right arrow, right arrow. That's it. I want that one, you guys. It's got the little circle with the tail and then down arrow to OK. Yeah, and hit enter. Okay, now Fick, go graph it. Here comes the first one. And then look, this has the little ball and it's like a little tail. And Fick, would you say it's the same graph?
Yeah.
Yeah. You guys, how cute was that? Did yours work with the little ball? Wasn't that fun? Did anyone do it with the little ball? Wasn't the ball fun? The ball's adorable. I know, you can change what the line looks like. And then here comes your little ball. Ah! Isn't it cute? It's so cute. Fick, thanks for being my model. Oh, yeah, he says, okay, you guys. Oopsies. Whoa. I just really put a big old picture in there. Boop. Okay. You guys, when we graphed both of them, did they overlap one another? I'm saying this is exactly this, but what we just did is we got rid of the hole. We got rid of the hole, and you're like, well, what hole was there? Well, let me show you. Here's what I need us to go to now. Could you all go to, this is going to seem a bit redundant. Now this Y2, I want you to clear it out. Clear out your Y2, and I want you to hit graph, and it should still have the same graph. And we said there's a hole at -3 something. Guys, could we go type in trace -3, enter. Trace -3, enter. Does anyone have calculator say -3 is your X and blank is your Y? It says because there's a hole. There is no Y value. Sound good? But did your graphing calculator show a hole at -3? It didn't. That's where our calculators are super annoying. There's a hole, but it didn't show it. I will let you see one screen that allows you to see it. Go ahead and do zoom. Option 4, zoom decimal. Yours should show the hole if you do zoom decimal. Does yours show the, oh yeah, look at that little Callie. Oop. Does it show the hole if we've got zoom decimal? Don't you guys agree it's right here? Oh, that does show up well. Right there. Okay. Are we always going to be in the zoom decimal screen? No. So that's why we got to be able to find the hole without our calculator, unfortunately. So here's the deal. We need to go find the value of that hole, and here's how we're going to do it. This was our function when we removed the hole. All we've got to do, you guys, is say, all right, I know the hole happens when X is -3. And we're going to go plug in -3 for X right there. If X is -3, what would we get on top, you guys? What's -3 plus 1? -2. What's on the bottom? -3 minus 2. -3 minus 2? -5. What's a negative over a negative? It's a positive. So you guys, the hole is at -3 2/5. And I'm going to go to my graph, and I'm going to say, all right, -3, and then I'm going to go up 2/5, and I'm going to draw a little hole. Does it have to be perfect at 2/5? 2/5 is about 0.4. And I'm just going to draw the hole. The last thing we've got to do is go find that vertical asymptote. I'm not going from here. I'm going from here. When does this denominator equal 0, y'all? When does X minus 2 equal 0? When X is 2. I love it. So I'm just going to say that's happening when X is 2. And I'm going to go to my graph. And I'm going to say I have a vertical asymptote when X is 2. Make that a dashed line. Don't make that solid. And that's as far as we'll go with that today. Okay, this guy. Did I already factor it for you? Love you. Is there a hole? Is there a common factor on the top and bottom? Where do we think that hole is going to be? At 4. At X is 4. You guys, I'm going to say that there's a hole when X is 4 comma blank. I don't know what the Y is yet. You guys, I want us to rewrite our function without the hole in it. We got a little X plus 1 on top, X and X minus 2 on the bottom. Then we're going to go plug that 4 back into what's left and see where is that hole happening. Where would it be on the top? What's 4 plus 1? 5. What's going on the bottom if X is 4? 4 times 4 minus 2. 4 minus 2 is 2 times that 4? 8. So we have 4 5/8. I'm going to go to my picture. I'm going to go right 4. I'm going to go up 5/8. It's just over a half. And I'm going to draw a hole. where is this denominator going to equal 0? That's how I get my vertical asymptotes. Do you agree my denominator is x and x minus 2? Look what we did on the last one. Before it was just x minus 2. You're like, cool, when does that equal 0? When you've got more than one thing, we've got to set them each equal to 0. When does x equal 0? When does x minus 2 equal 0? You set everything in your denominator equal to 0. You guys, is this one already solved? My x is by itself, right, Gladman? So x is 0 is one vertical asymptote. What about this one? X is 2. I would add 2 to both sides. So we've got 2 vertical asymptotes, 0 and 2. So I'm going to go to my graph. I'm going to say, all right, at 0, I got a vertical asymptote. And at 2, I got a vertical asymptote. So I changed the new denominator, if you will. Let's start with the new. In order to figure out if there is a whole, we have to factor. Because this is 2x squared. Am I tooting or O-tooting? I'm O-tooting. O-tooting is the worst, you guys. It's a Monday. I wish that we didn't have to O-toot on a Monday. Toby doesn't know what I'm talking about because he didn't do it. What are my O's? What are we multiplying together to be? 8. What are we adding together to be? 9. Okay, for a Jolly Rancher. What are my two numbers that multiply to be an 8, add to be a 9? Mad? 8 times 1 is 8. 8 plus 1 is 9. Mad, don't forget, when we go O-toot, we don't get to jump straight to the parentheses, you guys. With O-toot, we bring the first number. We separate the 9x, she said, into 8x and 1x. We separated that middle term into the two numbers that we came up with, and then you just bring the last term. Who remembers what to do next when we have 4 terms then to factor this? Toby wouldn't. Here we go. Who's getting out their magic wand to group these and tell me, what does that first group have in common? What's that first group have in common? Jules, what are we taking out? 2x. What's left?
X plus 4.
Beautiful. Hey, Jules, look what I have over here already. Oh, snap. And you're like, shoot, because I was here on Friday, I know that I have to have an x plus 4 over here. These have to match. Jules, what times x plus 4 would get me 1x plus 4? 1. She's like, I got to factor out a positive 1. The reason I've got to factor that out is because when we write it pretty, you guys, we need that to have a 1 there. If we left it blank, we would not get what we started with. So, Jules, if we wrote this pretty, we'd have 2x plus 1 times, girl, what color are you having? Okay, so, you guys, that's my new me. I just factored the numerator. Ooh! The denominator right off the bat, does that look like an O-toot? Right off the bat. But then you're like, wait, there's a GCF. Shar, what do you think my GCF would be down here?
2.
A 2. Shar, if I took a 2 out, what's left?
X squared plus 6x plus 10.
Plus, careful, take a 2 out of that 10.
Sorry, yeah, 5.
You got it. Okay, you guys. Now is this toot or O-toot now that it's x squared? It's just going to be a good old toot, and toot is so much better than O-toot. O-toot takes so much work, you guys. With toot, we get to just go straight to the parentheses. 2 is the little brother chilling. 2 is the little brother just hanging out. If I get to toot, what multiplies to be 5 adds to be 6. Mary Ebert. 5 times 1 is 5. 5 plus 1 is 6. And I get to jump to x plus 5, x plus 1. So good, Mary. Okay, here's what I want us to do then. Rewrite the numi over the denomi. We got y equals. We got 2x plus 1 times x plus 4 over 2 parentheses, x plus 5, x plus 1. I just put the factored numerator over the factored denominator. Do I have a whole? Does anything cancel out? Mr. Byers, do you think anything is going to cancel out? Do I have another 2x plus 1 down here?
Yeah.
Careful. I think you might be thinking it's 2x, but wouldn't that be a plus 2 technically?
Yeah.
Yeah, so they don't match. Do I have another x plus 4 down here?
No.
Any x plus 5s up there?
No.
X plus 1s?
No.
No. So guess what, Kai? We have no whole, and that's okay. We can just say none. Don't have to worry about it. Then to get the vertical asymptotes, you guys, It's when does the denominator equal 0? Do you agree my denominator has 3 things in it? People, we would separate them all. When does 2 equal 0? When does x plus 5 equal 0? When does x plus 1 equal 0? You might be like, I don't want to write this step. I don't blame you. You do not need to write this if we can think ahead. When does 2 equal 0? Never. We do not have to worry about 2 being a vertical asymptote. That's not a true statement. 2 doesn't equal 0. It's out. When does x plus 5 equal 0? Negative 5 is 1 vertical asymptote and negative 1. So we have 2 vertical asymptotes. This 2 just was chilling. I'm going to go to my graph, and I'm going to graph when x is negative 5, a little vertical asymptote, and when x was negative 1, a vertical asymptote, and we had no hole. If they're asking about holes right off the bat, we don't know if there's holes until we factor them. Who's factoring this top? Factor this top. What multiplies to be 3, adds to be 4 with toot? Fick? X plus 3 times x plus 1. 3 times 1 is 3, and 3 plus 1 is 4. Love it, Fickus. Fick, what about, I'll share. I'll give it to someone else. Who's factoring the bottom for me? Factoring the bottom, it only has 2 terms. We're subtracting between them, and they're both perfect squares. Anyone remember how to do difference of squares on that denominator? Who wants to take it? Who wants to take it? Gladman, you got this. What's that going to get me?
2x squared minus 3 and 2x squared plus 3.
So close. 2x plus 3, 2x minus 3. Going to take out that squared, right? Because when we multiply them together, we have to get a squared. Sound good, boo-boo? You guys, do we have a hole? Does anything cancel? I agree. We don't. We have no hole. My vertical asymptotes are going to be when this denominator equals 0. When does each denominator equal 0? Maybe this one you do have to write out, whereas the others were a little bit more straightforward. When does 2x plus 3 equal 0? When does 2x minus 3 equal 0? Maybe you don't have to write it out. I'm good either way. But what would we get if we did write it out? What would you do right here? What are we doing first? Subtracting 3. So we got 2x is negative 3. And then divide by negative 2, and we get negative 3 halves. What about over here? What's the only difference? We're going to add that 3, and then I'm going to divide by 2, and I get negative 3 halves and positive 3 halves. I might even write that like Plinus. I've got vertical asymptotes at Plinus 3 halves. So I've got to go to the right 1.5, draw myself some dashed lines. To the left 1.5, draw myself some dashed lines. And that's all we got to do.